All right, so compound interest problems are just an application of exponents. There are some words you need to be familiar with in this section. Okay, one is interest. Interest is money that's paid for the use of money. So when you put money in the bank and the bank gives you interest, they're giving you money to use their money. And when you take a loan out and they charge you interest, they are charging you a fee to use their money. Okay, principal is like your starting amount. It's either the amount that you borrow if you're taking out a loan or the amount you invest if you're putting money into a CD or into the bank. Rate is the amount charged for the use of principal per year. So rate is an annual rate per year, and it's always expressed as a percent. Okay, so if the interest rate is 3.2, it would be 3.2%. And now when we put it into the formula, we're always going to change it to a decimal. And so remember, to change a percent to a decimal, you move the decimal place back two places to the left. And so this would be equivalent to 0.032. So 3.2% is 0.032. 12%, move the decimal place back 2, is equivalent to 0.12. 5%, the decimal starts here, move it back 2, that would be equivalent to 0.05. Okay, so this is the compound interest formula. A is the ending amount or the final amount. Okay, so if you're investing money for 2 years, A is the amount you have after the 2 years. Principal is the amount you start with, the amount you put in at the beginning. Okay, R is the annual interest rate, and like I just said, you're going to put that always as a decimal. So if the interest rate is 5%, you're going to put 0.05 for R. N is the number of compoundings per year, and T is the time in years. So T will be how many years you've invested the money for. Okay, so you have to know these words and what they mean. These words will be in the problem, and they will tell you how many times the interest will be compounded or calculated per year. So annually, well, annually means 1. So if interest is compounded annually, then N would be 1. They would only calculate interest 1 time a year. Semi means half, like half semicircles, half a circle. So semi-annually means every half of a year, but that doesn't mean N is a half, it means N is 2, because they do it halfway through the year and then they do it again at the end of the year. Okay, quarterly, just like 4 quarters are in a dollar, if interest is compounded quarterly, then it's going to be 4 times a year. Okay, monthly, there are 12 months in a year, so if interest is compounded monthly, then N is 12. Okay, weekly, there are 52 weeks in a year, so if interest is compounded weekly, N is 52. And daily is 365, and we don't worry about leap years and things like that. It's always 365. Okay, so here's an example. Suppose that you invest $5,000 at 4.5% for 2 years. Okay, so $5,000 is your starting amount, so P is 5,000. I'm just going to write this over on the side. Okay, the interest rate is 4.5%. That's, you always look for the percent for R, but we don't write 4.5%, we write it as a decimal. So move the decimal place back 2 places, and R is going to be 0.045. Okay, we're investing the money for 2 years, and so that's going to be time. Time in years is going to be 2. Okay, so how much would you have at the end of the year? So we're trying to find the ending amount if interest is compounded annually. Okay, so if interest is compounded annually, then N will be 1. Okay, so go back here and look at our formula. Okay, A is equal to P, and then in parentheses 1 plus R over N, and then to the power of NT. Okay, so we're just going to fill into the formula. We're trying to find the final amount. The principal is 5,000. I'm just filling into that formula. 1 plus R over N. R is 0.05 over here. Okay, over N. Since this is annually, it's over 1. And then to the power of N times T. So 1 times 2. Okay, now when you go to put this in your calculator, again, you know, putting it in the calculator is probably the most challenging part. Okay, what I would do is you can leave this part in right here, 0.045 over 1, but just like we did when we were evaluating exponential expressions, I would evaluate the exponent first. So 1 times 2 is 2. Okay, now here's what it's going to look like when you go to put this in your calculator. Okay, so here's what this one would look like in the calculator. You have 5,000, just type it in exactly like it looks like on your screen. So parentheses 1 plus 0.045 divided by 1, parentheses, and then to the power of 2. This is why you want to do the exponent first. Okay, now this is money, so you want to round it so that the answer actually looks like money. Okay, so this is $5,460, and then round this to the nearest cent. So it's 0.125, so we'll round that to 13 cents. 54.60 and 13 cents. You don't want to put 0.125 because that wouldn't make sense because this is money. Okay, now the only thing that changes in the next one is that now we're compounding monthly. So if we do this monthly, now n is 12. So you have 5,000, 1 plus, this is still 0.045, but the n that was 1 now changes to 12. Okay, now up here in the exponent, n is 12 and t is 2. Okay, but you want to do this part first. So do 12 times 2 first, and when you put it in your calculator, go ahead and put it in as 24. Okay, so here's what it's going to look like in the calculator. If you hit second enter, it'll bring up the same screen, the same thing we just typed in, and now I just need to change the 2 to a 24. Okay, so this is, oh no, I need to go back here and change this one as well. Hold on one second. I can insert. Okay, so this n changed to a 12 and the exponent changed to 24. Okay, so in this case, we'd have $5,469.95. Okay, semi-annually is 2 times a year. So now the formula would look like this: 5,000, in parentheses you have 1 plus r, still 0.045, but now n is 2. Okay, and the exponent should be n times t, which is 2 times 2, but I'm not going to write it out like that. I'm going to go ahead and write that as 4. Okay, so here's what this one looks like when you type it in. And the answer should be 54.65, and then this is going to round to 42 cents. Okay, so 54.65 and 42 cents. Okay, for daily, you would do the same thing, only now n is 365, so it's going to be A equals 5,000, parentheses 1 plus 0.045 over 365. Okay, the exponent's going to be 365 times 2. Okay, so that's 730. Okay, go ahead and try and type that one in your calculator. And then put the answer that you get into the question. Just a second. Okay, here's what you should have gotten. All right, so let's try this one. In this one, we're trying to work the other way around. We want to know how much should you start with if you want to invest your money for 3 years in an account that earns 8% interest, compounded quarterly, and at the end, you want to have $7,500. So now we're trying to find P, and we know A. Okay, so let's write out what we know. We know that we're trying to end up with $7,500. We know that we want to invest the money for 3 years. We know that the interest rate is 8%. Okay, but 8% as a decimal is 0.08. And we want to compound it quarterly, so n is 4. Okay, so here's the formula. A equals P, parentheses 1 plus r over n to the nt. Okay, so A is what we want to end up with, 7,500. We don't know what P is. That's what we're trying to find. R over n is 0.08 over 4. Okay, and then up here you have n times t, so n times t is going to be 4 times 3, or 12. Okay, now for this one, what you want to do is type this part over here in your calculator first. So I'm going to just do this part over here. 1 plus, parentheses, 1 plus 0.08 divided by 4 to the power of 12. Okay, so this number over here is let's see what we have. 1.26824. 1.26824. Okay, 7,500 is equal to this. Okay, so what we want to do is we're trying to solve for P, so we need to divide by this number over here. So to solve for P, you're going to have 7,500 divided by 1.26824. Okay, look at the equation. If I divide both sides by 1.26824, 0.26824, okay, this part over here is gone, and P is equal to this over here. That's the same thing I wrote on this side. Okay, now a trick to do this in your calculator is to type in 7,500 and then hit divided by, and then you can hit the second button, and right here, see where the negative is? It says answer. It'll divide 7,500 by the previous answer, by the 1.26824. Okay, if you type it in with the rounded answer, you're going to have 7,500 divided by 1.26824. Okay, it's pretty close to the same answer. It's off by a penny, maybe 2 cents. Okay, so it's better to divide it by the previous answer. You get a more exact answer. So the answer would be $5,913 and then 70 cents. Okay, if you did it this way, you'd have 71 cents. Okay, so it's really close. I'll give you credit for either one, but just know that this one up here is the more accurate answer, the first one. Okay, this one's similar. How much principal? How much do you need to start with? If you want to invest your money for 10 years, so now T is 10, in an account that earns 4.5% interest, so if you move the decimal back 2 places, that's 0.045, compounded monthly, so N is 12, and you want to end up with a final amount of 15,000. Okay, so we'll plug this in the same way. Remember the formula is A equals P times 1 plus R over N to the NT. Okay, so the final amount's 15,000. We're trying to find the principal. The interest rate is 0.045. Monthly, so 12 times a year. Okay, so let's figure out NT. NT is going to be 12 times 10, or 120, so that's going to be the exponent. Okay, so just like before, we're going to do this part over here first. Oops. Okay, so I'm going to type in parentheses 1 plus 0.045 divided by 12, parentheses, to the power of 120. Okay, so this part over here is 1.56699. 1.56699. Okay, so if we're trying to solve for P, you want to divide both sides by 1.56699. 1.56699. Okay, that'll solve for P. So I need to do 15,000 divided by the answer I just got. Okay, so I'm going to type this in as 15,000 divided by, then I'm going to hit second. I'm going to hit the negative for this little answer thing right here. Second answer, and hit enter. And that's my best answer right there. 95.72, and that would round to 48 cents. 95.7248. Okay, and that would be how much we need to start with if we wanted to have $15,000 after 10 years. All right, you guys have some problems on your sheet to try, so you need to finish these and then turn this sheet in with all of the notes and these problems worked out. You can go back and rewatch the video if you need to see the examples worked out again.